Good afternoon, everybody. My name is Greg Bry. I'm with Solar Power International. So today we have Brian Patterson along with us, and Brian will be talking a little bit about microgrids, the future of microgrids, and at the very end we'll go into a little bit more about North America Smart Energy Week, which includes Solar Power International, Energy Storage International, the Smart Energy Microgrid Marketplace, which we'll be featuring today, hydrogen and fuel cells, and the technical symposium. So without further ado, I'll introduce Brian Patterson. Brian is the president and founder of Emerge Alliance. He's a 30-plus year veteran of the electrical and electronics industry, and he really spearheads our Smart Energy Microgrid Marketplace at SPI, which there's a lot going on, and I think you'll find out throughout his presentation, Brian is very knowledgeable in the microgrid space and connecting technologies. So Brian, I'll hand it over to you.
Thank you, Greg. Just a real brief word about Emerge. If you'd like to find out more about Emerge, we're a nonprofit that works on Vanguard standards and promotion of renewable energy technology through microgrids and DC coupled microgrids and hybrid microgrids as well. You can look us up at emergealliance.org. So today's webinar is going to try to cover all these subjects. We're going to talk a little bit about microgrids in historical and future terms, about the transformative capability that they have, and some of the challenges that we see going forward. And then at the end, we're going to talk a little bit about what's going to take place at the North America Smart Energy Week conference and exposition that Greg mentioned, and we'll go into some of the related events that will be at the conference. If you have questions during the presentation, please record them in writing on the Q&A button you can push, and that way Greg will get it and get it over to me when the time is appropriate. So without further ado, whoops, hit the button too many times there. Let's see if we can get started. Now, some would have it that Edison's Pearl Street Station, that some of you have probably heard about, a direct current generating station that's in New York, that also produced steam in a combined heat and power scheme, was the first microgrid. Others would point to the plant that's co-located at Whittling Refinery in Indiana, which is also a combined heat and power plant at a grand scale, much bigger than Edison's Pearl Street Station. Edison's Pearl Street Station was the DC microgrid. The Whittling Refinery was an AC microgrid at 64 megawatt scale. But when we look at the history of microgrids, it's important to sort of note that to call something a microgrid, it has to have meet a certain requirement. Both of these examples that I just mentioned do meet the strict definition of a microgrid, but they skip over one of the most sought after attributes, at least in the current context of a microgrid, and that is the ability to effectively integrate renewable energy sources. And since most renewable energy sources are intermittent and not dispatchable on demand, this generally implies that energy storage is also a key element in an effective microgrid. So where in history did storage first come on the scene in a serious way? Well, you can look back to 1917, circa 1917, when a company named Delco was formed. That's right, it's the same Delco that was later to become part of General Motors, the automotive giant. But unfortunately, although almost 2 million of these type of microgrids were deployed between 1917 and 1955, few actually utilized renewable resources, and none were connected to the grid. So this means that they also were all direct current systems, and the grid was alternating current if it existed at all where these microgrids were located. So there was no really practical way to meld the two into a grid-tied system. So as you may have guessed, these systems were spin-offs from the emerging automotive market with vehicle electrical systems that were DC based. They were actually first developed by a fellow by the name of Charles Kettering, who was later known for his philanthropic, probably better known for his philanthropic work in the support of cancer research, the Sloan and Kettering Research Foundation. But he was also the inventor of these systems that were all based on his primary invention of the electric starter for combustion engines, which was used in both the automobile and in these microgrids. So what he did with that automatic electric starter was he invented a device that used a voltage droop to activate the motor driven generator, which is combustion, that served to charge the batteries and maybe even simultaneously at times maintain system voltage when there were heavy loads. So pretty amazing stuff for 1917. And just for fun, he also invented the electric refrigerator with a product called, and maybe some of you will recognize it, called the Frigidaire, which utilized compressed gases also for cooling instead of physical ice, as ice boxes were known. So as history tells it, most of these systems were abandoned, though, shortly after World War II, as rural electrification brought the grid out from the city to power most of these rural locations. Others will point to the central office of the telecommunications industry, notably operated by Ma Bell, and say, here's where microgrids really started. Okay, they were grid connected. They were islandable, which is another part of that definition requirement. And they had storage, batteries, massive amounts of batteries. But whoops, once again, and there were no renewables. So in today's context, they really weren't the beginning of modern microgrids as we're starting to know them. So the logical answer to the question of where the first microgrids actually were deployed is something around the beginning of this century, the 21st century. Well over 100 years, close to 120 or 30 years after the first grids were actually developed. I'm going to say that personally, it was 2001, because that's the year that I personally started working on small solar-powered and battery-backed-up power systems. But it was about this time that we added one additional and necessary consideration to call something a microgrid. It had to practically include an effective integration of distributed renewable energy, which generally meant that storage was no longer an option because, as you know, most distributed renewables are not dispatchable. And if you don't believe me that that's a modern requirement, even though it's not contained in the Department of Energy definition of a microgrid, you can ask the New York Power Authority, because recently, just this year, and just a few months ago, they announced the project up in Albany, the Empire State Plaza project, power project, and they were about to go out for contractors to start on it when it was halted by a public outcry because the plan, although it was called a microgrid, had no renewable energy sources and or even their stored derivatives like hydrogen or so on. So here was public outcry saying, hey, you can't call this a microgrid if it doesn't do something for renewables and the environment and so on. So they're back to the drawing board, by the way, and that project is in significant delay. Suffice it to say that the modern context of microgrids, the industry of microgrids, is just beginning to evolve now. And from the early beginnings of small solar and wind-powered microgrids like the one operated in the picture on the left here by NTT facilities in Japan, it was in fact the only power station to survive the tsunami that followed the Sendai earthquake in 2011. So that is really, in the modern context, a really resilient microgrid to where now there are hundreds of residential, commercial, and technical, municipal, and military microgrids. And close to the place where I was born in Brooklyn, New York, I was actually a Queens kid, but on the other side of the island, in Brooklyn, New York, you see the beginnings of microgrid integration into residential and light commercial properties. So it's really, at this point, here in 2018, it's game on, really, for microgrids. At least that's the way I see it. You may or may not agree. But I know you didn't come here to hear about history. You wanted to hear about the future of microgrids, but I thought it was important to kind of set the goals for future considerations properly. And it's important to understand that the future not only includes a technical path forward, which most of us engineers like to talk about, but must include the social ones as well. And hopefully we'll find a few anthropologists in the audience today to help me balance off the probable preponderance of engineers listening in. Where in most cases, the future is enabled by technology. There's no doubt about that. But it's very much guided by social behavior and social habit. So stick with me for a few minutes while I explain what's really likely to be important in predicting the path for microgrids in the future. The human or social influence on things tends to transcend technological order. All of these wholly human desires will have pronounced impact on the way microgrids evolve going forward. Take personal control, for example, particularly as reinforced with personal computational facilitation. That means the personal devices that we have and the capability that we now have based on personal digital assistance. It means that most people are eager to wrestle control away from central control experts. That is, provided they have the keys to the policy algorithms through their personal devices, and that those personal devices now include distributed intelligence, which means that you don't need to be an expert to operate as an expert in systems going forward. There is this notion of distributed intelligence that the internet and personal digital devices have given us. So that further evokes the desire for self-sufficiency. And self-sufficiency in one context is really based on personal survivor instinct. But it's increasingly motivated by the fear of infrastructure failure. And one only needs to think back to Sandy and other major weather events and near man-caused failures in electrical systems to understand this kind of desire for self-sufficiency. It really doesn't matter whether the threat is from natural, mostly weather, of course, related, or man-made, mostly terrorist-related fears. The next one is consumption and conservation. You can look at it either as a glass half full or half empty. But this personal value is driven, and decisions against this are driven by personal value, and therefore fewer and fewer of us are willing to entrust governments and other regulatory or regulated decision makers to make these decisions for us. Whether we fall more on the conservation side or more on the consumption side, and freedom in either direction, the tendency today is to not trust others in making these value-based decisions that are human instincts and values. It also includes the two faces of green, therefore, both the environmental green as well as economic green, or greenbacks, as some people would say. And last but not least is entrepreneurship. Entrepreneurship, at least in my understanding and my experience, is largely a social and human driven instinct. And it's more likely to be supported in social ways, particularly if the social tools and systems can be used. And this is really evident when we look at systems that are based on social order, like eBay and Letgo and Amazon, Facebook, and all the other ways that people relate to each other in this massively interconnected information system, which now needs to do work and perform the promise of productivity and creation of wealth that it long has held out for us. But on top of this comes some really big technological accelerators and killer apps, if you will. All kinds of new and dynamic electrification needs, largely spawned as a result of the success of the internet. And I simply call it the electrification of everything. Because electricity is one of the most efficient and versatile forms of energy, most other forms are waning while electricity use is waxing. and that's a good thing, because we're using less energy but more electricity, if you can wrap your head around that. And that's because a lot of the new capacity in electricity will be coming from technologies that have a free or largely sustainable fuel source. And that is, most of them are going to be directly or indirectly generated from the action of the sun. So that's a real major influence, is this huge trend towards electrification. The human and social influence on things, therefore, because of all of the above, really tend to transcend the logic of just technology and physical science. These wholly human desires have a truly pronounced impact on the way microgrids will evolve going forward, at least as I see it. As such, microgrids will reflect the strengthening human desire for a few important considerations. Personal control, again, as reinforced by personal computational facilitization, means most people are really ready to take over. That move towards self-sufficiency and so on, as I mentioned before, are all human drives. So taking some personal liberty in making the translation from human desire to physical science, I've made this list of things a microgrid will likely technologically have to embrace. I'm not going to go through all of them, but I will comment on a few of them. As I said before, the consumption-related drive toward control of energy and the use of microgrids is that they will allow you to embed real local values and policy into the decisions based on consumption or conservation. Also, the whole move toward the personal Internet of Things, which is another everything kind of thing, it's digitalization of everything, really does force a consideration of change, at least at the fringe of the power distribution. And that is that most of these digitalized things are electronic, which means they use DC power. So there's a tendency to think more and more about how DC should be played into these microgrid systems, either as sources or outputs or both. Of course, I mentioned the mass integration of renewables, and this means that microgrids need to favor, if you will, the ease of integration of renewables, again, which largely are not dispatchable and in fact mostly DC based. So again, microgrids either internally or otherwise will favor the use of DC, particularly at the lower voltages that most of these systems generate power at. So those are all important, and I think again the social reflection that I mentioned is also going to manifest in the sense of a mesh interconnect of microgrids, or as some people are now calling it, the grid of grids. This really does follow the normal social order of human behavior, just as personal computing evolved into these mesh networks of information. We're also going to now do the work that information is indicating that we can do, and we need energy to do that. The best energy is going to be electricity. It's easy to articulate and monitor and control and apply. So a mesh network which embeds this distribution of electricity is probably one of the most likely manifestations. Whoops. Some other key attributes is that microgrids aren't going to be able to stay with just considering one additional source to the traditional grid source of electricity. More and more, we're going to see other ways of harvesting energy, either from renewable or human, I'll call it harvesting of recycled energy. So it's important that microgrids be designed with a way to combine many different sources of potentially dissimilar types of electricity, although most of them will probably be DC based. It also means that because we have all these different mixed sources, that conversions need to be focused on as being the most efficient. And obviously simple conversions are better conversions. And so I think there'll be an emphasis on conversion technology within the microgrids. And then, as I said, microgrids are really the enabler for implementing policy and human values into the electrical system, both in terms of source and load. So microgrids are going to have to deliver on intelligence and analytics so that users can select their values and policies to be implemented within the microgrid. I mentioned the mesh connectivity, but along with that comes peer-to-peer connectivity and probably leading to some form of retail trading capability. Perhaps, as some people see it, as a blockchain capability for general ledgering of either arbitrage or trading of power. And I think that we can't ignore the fact that we have a huge legacy system of AC, which still is one of the best engineering feats in the history of mankind. So we don't want to marginalize the investment we've made in AC power. So microgrids need to support both AC and DC inputs and outputs. Because it's an emerging and evolving technology, particularly now, microgrids need to be designed to be scalable, if not modular, but also to have a certain level of interoperability, because as time goes on, there will be disparate advances of technology by different entities, and interoperability will be important to maintain a economic stability from a user's perspective. And of course, it's not often talked about at this point when people talk about the behind-the-meter microgrids, but utilities are already utilizing microgrids for grid support capability, and I think the mesh network that goes what we're calling behind the meter, if that term even survives going forward. Grid support capability or total system support is an important attribute that future microgrids will need to embrace. So different types of microgrids. And a lot of people say a microgrid is something that's in a building, or it's owned by a utility, or it's just something that is only available for special applications like data centers, what have you. But microgrids are all of the above. So just to look at some of the attributes, I'm not going to read through this, but as I talk through it, you can read some of the attributes that I think go into some of these market spaces. And each of them really dictates some changes, at least, or flexibility in the way microgrids might be designed. In other words, there's not one shoe fits all here, because there are considerable disparity in the categorization by size or output or sourcing or location, et cetera. So certainly residential, which might overlap with small retail and multi-tenant kinds of microgrids, are going to evolve. And again, ones that can be, if you will, interconnected or networked in some fashion to do sharing. Same thing on the commercial side, commercial buildings, office buildings, retail stores, college campuses, et cetera, et cetera. Again, perfect avenues for microgrids to proliferate, and whether it's in a community a business center or a college campus, what have you, to share resources across a wider scope of geographic space. And then there's this space that I call technical microgrids, but it includes the microgrids for data centers and central office telephony and cable head ends and so on, where you might not think of them, owners of these systems, as consumers, but they are, and most of them are considered inside the meter systems. So that means they have their own power nuances that they deploy in those systems. The motivators there are different, for example, than they are in other areas. Probably the number one motivator is reliability or surety of uptime. Efficiency is way down the list, as is going green. But once you address the first few issues, the other ones neatly follow behind. Probably one of the big new ones is in the transportation area. In particular, we could talk about lots of different transportation, marine and the rail and so on and so forth. But the big new one here is fast charging for electric vehicles. And this is an interesting one because it may change the way even utilities think about how far they go with their systems into what would normally be considered the private enterprise space. And that's because a typical service station that's going to charge, let's say, 8 or 10 vehicles at a time is going to be a multi-megawatt requirement. And again, looking at social behavior, it's not, we can't depend upon, and it's not likely that people are going to be self-disciplined to charge their vehicles at night, and according to the neat little model that fits the duck curve, or is complementary to the duck curve, if you will. Most people, some people don't even have garages. So, and a lot of people are used to stopping in the morning for their cup of coffee and donut, if you will, on the way to work or on the way home. I notice that there seems to be a peak in charging already in vehicles at 3 o'clock in the afternoon, and that's when a lot of light vehicles and particularly blue-collar workers, if you will, are coming home. So they stop and want to charge their car and stop for a refreshment or what have you. So that's not likely to change, and that puts a tremendous demand on the branch feeders that would be downstream of substations. So needs to be a lot of new thinking there as to whether the utility owns some of that infrastructure that needs to use power electronics to support the individual charging stations, and whether or not, for example, that DC becomes, because these fast chargers are all DC at higher voltages, typically in the 600 to 900 volt range, which means probably a backfeed service of around 1,000 volts in megawatt levels, and it's causing a lot of folks to think about DC as a service, whether it's from the utility or from third parties, to support the owners of these service stations. So there's lots of action there, and it's a big piece of the puzzle, if you will, if you go back to the amount of additional electrification that will be required to power our vehicles as we move toward that electric paradigm. Then there are utility scale microgrids. They started early in the game, so to speak. Utilities have long been interested and are starting to operate microgrids that are essentially, whether they're renewable energy based or not, they provide particular grid support for peaking and for frequency and voltage support and things like that, even VARs and so on. So these systems tend to be fairly large scale, and more are utilizing renewable resources to add to the electricity generation scheme going forward. And last but not least are remote microgrids, which sometimes people think of as the first example of microgrids, generally, I think it's going to end up being lesser than some of the other spaces in the microgrid market. But certainly, particularly when you think of underdeveloped countries, particularly in South Asia and India and sub-Saharan Africa, where the population growth is particularly large, and the percentage of people who have access to electricity is typically under 30 or 25% of the population. And we're talking about an underserved population of 1 to 2 billion people when you add it all up, for those that are partially served and those who have no service. So this is certainly going to be an expanding area for microgrids to go after. And while they may start off being off-grid microgrids, they really need to be designed and thought about as being eventually grid connected or interconnected, for sure. Whether you want to call it the grid or not, they need to be interconnected as a grid of grids at the very least. So now that's an important consideration for those thinking of entering the microgrid business in these remote, underdeveloped areas. But there's also a market emerging from just remote microgrids, even in developed nations, where the cost of running power service, the infrastructure, the physical infrastructure to remote places is incredibly expensive, and sometimes fought tooth and nail with the folks who don't want the landscape to be modified. So there's lots of things going on in that area for microgrids, and most of them are small because they do service remote users of electricity, like cell towers and things. But they're very important and certainly a piece of the overall market. So all of these markets have different motivators. I've included this slide here as all of these slides. If you didn't get to read all of it on the slide, this presentation will be available, and you can pick away at it and go back and look at the detail. So what are the key challenges then for microgrids in the future? Or you could say starting now. I think one of the biggest by far is the regulatory challenge. The whole process of deciding how new market entrants are going to be allowed to come in and potentially trade electricity, and the requirements for that are really being evaluated differently all over, and different than what happened in telephony, where essentially the regulatory apparatus in telephony was very focused and concentrated in a sort of a national way in the Federal Communication Commission. It's different in electricity. You all know that the regulatory apparatus here in electricity is really split up into almost local domains. And yes, there is a Federal Energy Commission, but it really only has a small piece of the action as compared to the state public utility commissions and so on, and municipalities beyond that. So that whole question of how those regulatory apparatus, or that regulatory apparatus, is going to deal with all this new stakeholders in who want to enter and trade and deal with the new aspects of the electricity system, particularly at the fringe, is probably one of the most difficult problems. Then there's a question of tariffs and how do you support the existing infrastructure if we start to shift some of the functionality and investment to these new pieces. What happens to the legacy systems, and how do we deal with that from a tariff standpoint? Obviously, we can't afford to let it collapse. That would be a disaster, and would be foolish, because in the long run, just like in computing, the so-called bulk grid becomes the equivalent of the cloud and some other features. So no room for mistakes there. We really need to figure out how we're going to support the existing infrastructure, even as it goes through these rather significant transformations. And then there's the whole question of interconnection rules. As I said, evolving from sort of a hub and spoke or dendritic type infrastructure to one that is mesh based. It requires the development of interconnection rules and protocols that will allow for that to take place in a safe and effective manner. And then the regulations need to provide for a fair and balanced investment. We know that there are investment incentives that are afforded to utilities and co-ops and so on, but some of that needs to be expanded into this new prosumer domain, if you will. Also, beyond regulatory is this whole question of standardization. If we're going to have interoperable systems, particularly on the electrical side, and in terms that provide for the utmost safety, which is a consideration that was less of a concern in information exchange as it will be in electrical exchange. Interoperability, standardization, and safety is an important piece of this whole puzzle. And I see all of the major organizations, the IEC, the IEEE, and with the help of folks in NEMA and eMERGE and other organizations are all moving fairly rapidly now down this path, but we need to continue to keep that effort going despite its velocity and the mismatch of its velocity to the traditional timing that usually exists in standards organizations. We need to push hard and we need to keep going until we get the kind of level of standardization that will both economically and from a safety standpoint provide the right solutions. And of course, since this is really a merger of the internet and the grid, so to speak, communication protocols really do need to be addressed. Now, we do have in computing, the capability to have Android and PC-based and Apple operating systems, iOS and so on, all survive and exist together. And probably the message there is that gateways will become important to share information between different protocols. But those gateways need to be pretty open protocols so that there is a free and fair exchange of communication information that will have both the economic and safety implications. And last but not least, and one of the things that we found probably in the last couple of years now is that in order for the regulatory folks to really see their way clear on the score of fair and balanced and economically fair, there needs to be a development of DC revenue grade metering. Even if DC doesn't become a primary distributed form of electricity, microgrids tend to be that what I call gazinta-gazetta systems, where you have a combination of DC and AC, and you need to know where the DC is going, how much, and where the AC is coming from, and so on and so forth. That DC revenue grade metering is a key piece that is being worked on pretty vigorously at this point. So the way forward for microgrids in the next few years, and it is rapidly starting to gel now, as you can see and read in the literature and in the journals and so on, is that the future for microgrids is really a bright one and a great one and a fantastic new opportunity for almost everybody involved in electricity, from new entrepreneurial startups to traditional big scale utilities. We need more electricity to carry out this electrification that I talked about, and the microgrids can help do that. We need clean electricity, and microgrids and their capability to bring a greater emphasis to renewable and sustainable clean energy sources is key. Microgrids are in a way a complementary infrastructure in that they rely more on local infrastructure and not long distance infrastructure. So less battles over where the wires have to go and so on and so forth, although I'm sure there'll be some, and some people don't even like the looks of solar panels. So there's always a few battles that'll have to be fought there, but microgrids by and large provide for a much more complementary infrastructure, and that they provide for this capability of self-sufficiency and islanding and so on. So they really feed into the area of reliability and resiliency. Reliability, the ability to stay up, and the resiliency, the ability to recover when there are faults, are both really strong attributes of what microgrids are able to do. And last but not least, from a macro-social standpoint and world economic standpoint, microgrids are probably the best way to allow electricity or make electricity accessible to all, no matter where you are in the world. So microgrids are likely to be the core of this evolving grid of grids going forward. So that's what I had to say about, and what the members of eMERGE and others that we deal with are saying about microgrids and the future of microgrids. Again, we think there's an incredibly strong future for microgrids. I implore the engineers among us to make sure we understand the social motivations behind the transformation in electricity grid structure and microgrids and so on, because they're going to come into play more and more as we go forward. Now I'd like to talk a little bit specifically about what's going on at the North America Smart Energy Week, which is the September 24th through 27 out in Anaheim at the Anaheim Convention Center. This is an event that I think Greg mentioned is held by Solar Power International, and it's really now almost a co-located show of shows. It incorporates the traditional Solar International. It added a few years ago energy storage, which is probably the biggest growth area over the last few years, but now includes a Microgrid Marketplace, which we started just a couple years ago and is growing. You'll see a bigger Microgrid Marketplace than ever before, and now has even included North America hydrogen fuel cells, another energy source. So the show is broad-based. One of the things that will happen at the beginning of the week is that there is a Microgrid Workshop. For those folks who really focus on microgrids and want to get in depth with some of the folks who have been deploying microgrids and explore their use cases and see exactly how things are being done in this area. We have a Microgrid Workshop scheduled on Monday. It runs all day. The end of that is a visit to the show floor before the show opens to visit the live microgrid that's going to be there, which in fact is going to be powering the space that we call the Smart Energy Hall. So all the booths in that area will be powered off a microgrid that is actually being demonstrated and exhibited in the hall. So if you want to get involved with that, please check out the website for North America Smart Energy Week and look for the Microgrid Workshop that's on Monday. After that, we have, as I mentioned, an expanded area that we call the Microgrid Marketplace. More exhibitors and more demonstrations than ever before, and we're adding a new feature there, which I'll talk about in a minute. But the Microgrid Marketplace is now one of the fastest growing halls in the combined show that we now call North America Smart Energy. In the marketplace, one of the features there is the theater where presentations are going to be given just about every half hour. So there's more than 20 expert presentations expected to be given, many of them given by people who are at the show and have booths and have equipment there that you can learn more about. We do open that whole session with a plug pulling ceremony. We kind of show the first mode of a microgrid to go to island and to seamlessly island without bringing down the power in the hall. And each day will end with a panel discussion. And the panel discussion topics are, one is about regulatory challenges, some of which I already mentioned, but in much more detail from true experts. Another one is on the stacked value proposition for microgrids. So whether you're a buyer or a seller, technology in this domain. The stack value proposition discussion promises to be a good one. And then we're going to debate over whether microgrids should be standalone, which is the way most of them are today, or should they be interconnected into this grid of grids, as many people are suggesting. So that'll be an interesting panel discussion. Each of those panel discussions will end at pretty much the day of every day. A new feature of the Microgrid Hall will be the title here. I'm sorry, my bad. I forgot to change it. It's actually the Microgrid Clinic, Ask the Experts Clinic. So what we have is we have assembled a team of experts in a lot of different categorical fields of microgrids, from an equipment and or market space, and they will be available every day that the show is open, that the exhibit hall is open, where you can just walk in and talk to the experts, and if one expert doesn't know the answer, they'll just point out to another one, which is at the next table or so on. So we think of it as a walk-in information clinic. You don't need to go hunting around the show floor, although I'm sure the experts will know where all the booths are that might be valuable for you to visit once they understand what your need or your questions are. But it's a great way to get immediate information or guidance if you're exploring this whole area of microgrids, either as a supplier or as a purchaser. So we hope to be able to answer most of your questions on the spot. And if we can't, I'm sure you'll get to network and meet with people who will follow up for you. This Ask the Experts Clinic is right next to the Microgrid demonstrator, which is in booth 4146 at the show. We also are going to be giving little mini, I call them micro break tutorials, in the upstairs section of the show, which is the educational pavilion, if you will. And we'll have some displays up there, and we'll have the video dashboard from the microgrid that's operating on the show floor. And periodically, I think 3 or 4 times a day, there'll be a tutorial that's given during the break times between educational sessions, so it won't interfere with your ability to attend the educational programs. But it'll be a free experience for people, whether you're part of the educational program or not, and may give you a taste for getting involved if you haven't already been involved in the past. All of this, by the way, has been largely made capable by a bunch of very motivated companies and organizations. I mentioned eMERGE, but SIA and SEPA, the 2 major organizations that support this show and produce it, are very involved in making this all happen. And we have representatives from all the companies that you see here that help design and equip the demonstration microgrid that will be on hand for the demonstrations and in the Ask the Expert area and so on and so forth. So I kind of want to give a shout out to all of those folks, especially the folks at NSYNC who have helped sort of organize with the eMERGE a lot of this effort. And also, I want to shout out to Dave Geary from Comcast, who has also been heavily involved in helping us organize and actually engineer the whole system. I'd like to point out that the major companies there, I'll go through them real fast because they have some really interesting new stuff going on. CE+T Energy is a company that really specializes in enhanced conversion innovations, what they call ECI. What's neat about this is it's kind of bi-directional, but it's actually multi-legged, if you will. So you can do AC and DC inputs and outputs that really provide for not only high efficiency, but also secondary kind of functions like phase balancing and battery testing and added redundancy and so on. And their systems are microgrid ready, and an ideal for many the technical and commercial applications that I talked about. And the efficiencies in their systems are very high. And I know some of the other companies in the space are actually using some of the embedded CE+T technology. So you'll see what they're doing. Another shout out for a company called Connet, who's providing a lot of the power distribution, secondary distribution off on microgrid. And they have some really neat modular designs with both bus and busless configurations that allow a really super convenient and effective arrangement of power protection and distribution, with a lot of good communication that you'll see manifest when I talk about monitoring and so on in a second here. But Connet is going to be with us, and they'll have some equipment that provides some of that distribution from the microgrid. I mentioned InSync already, but InSync is a company that specializes in something called auto-sync DC buses, and I wasn't really sure what that meant, so I got Ben Williams, one of their product managers, to come on. And Ben, are you there?
Let me introduce Ben Williams, a product manager with Smart Energy Systems, a US-based manufacturer of, among other things, something called auto-sync DC bus microgrids. Hi, Ben, and just what is an auto-sync DC bus microgrid?
Hi, Brian. Good to be here. So, Smart Energy is direct current centric in our philosophy and technology. So we allow clients to derive exceptional efficiencies with innovative hardware and software that integrates all DC and AC system inputs. So AutoSync is shorthand for automatic synchronization of all available electricity from any given resource to ensure those efficiency. And it sources it in the most effective manner in or out of a facility. AutoSync DC bus, which relies on voltage bands, is the architecture inside the Matrix Energy Management platform and at the core of all Smart Energy technology. It's what allows us to derive the least expensive, most reliable energy for clients.
And as people head out for the North American Smart Energy Week and our very unique live Microgrid Marketplace demonstration, what will they see from InSync there?
Yeah, we're excited to feature our Matrix Energy Management platform and our newer energy exchange software through a product we just launched on the market called NSYNC Home Energy. Part of the live microgrid will be 2 NSYNC home systems with storage and PV that will be powering a number of trade show booths. We'll be featuring our peer-to-peer energy exchange between the 2 units, which highlights the capability for direct exchange of energy within a community of networked units.
Wow, that's fantastic. I think that's going to be a first at the show. We haven't had residential units talking to each other like that or linked together, so that's going to be exciting. But what is the one message you hope people walk away with from the show?
I think that would be that microgrids are no longer limited to R&D projects. They're commercially viable now and a key solution for integrating distributed energy resources. And of course, that Smart Energy has that deep experience helping customers meet their goals of resiliency, sustainability, and equally important, lowering energy spend with our DC-centric platform that simply integrates various resources in an easy-to-manage system.
Hey, well, thanks, Ben, for joining us today for this kind of sneak preview. And oh, by the way, will InSync have an expert in the Ask the Microgrid Experts Clinic, a new feature on the show floor?
We will. So in addition to myself, we'll have our distributed energy resource software expert on site, our specialist in large-scale systems like data centers and multi-megawatt facilities, as well as NSYNC's business development team.
Hey, well, thanks. That's great, Ben. And we'll be looking forward to seeing you and the rest of the NSYNC team out there.
Looking forward to it.
Okay, I confess that was canned. But thanks to Ben for helping me out there and giving you a little bit of a perspective on one of the systems that, or actually 2 of the systems that will be there. Also, we have Next Tech Power Systems will be there. They have shown a variety of things over the years, but the newest of which is really these intelligent, as they call it, PhD distribution units that distribute low voltage DC out to loads, including USB and PoE and so on. So there's some really interesting integration that's going on at the final distribution, particularly of DC direct that is capable of doing things driverless LED lighting and as I mentioned, USB and PoE kinds of systems. So they'll have some equipment that's working off the microgrid and actually providing some USB support in the Ask the Experts area. StarLine Solutions has long been a supporter of DC solutions in microgrids and will be demonstrating the latest of their busway technology, which includes DC very accurate metering, so we can keep track of what's going in and what's going out from a DC standpoint. Their equipment really provides the type of interconnection we talk about at the core, and also we're going to be demonstrating one of their lighting buses that operates off a higher voltage DC and 380 volts. So pretty exciting stuff. And again, it connects all of our microgrid stuff together, or they connect all of our microgrid stuff together, particularly on the DC bus side, and provide that lighting bus as well. One of the new things at the show for the first time demonstrated will be digital power. And I mean real digital power. So it's not DC, constant DC, but rather digital DC. And we're going to be demonstrating that. So again, the server technology that provides a digital DC to equipment that has receivers either external or embedded in them, so that a very, very safe and effective and efficient distribution system can be enabled with the use of digital power. And like I said, it's not power of digital things, it is literally digital power. So if you're not sure what that is, and I'm still a little bit sketchy on it myself in terms of how it works, I just know that it does work because it's been demonstrated to me, and I'm still trying to get my head wrapped around it. It's such a bold new approach that I think you'll be really excited to see it and interested in using it in some of your work going forward. Last but not least is Worldwide Environmental Systems, who is providing some real-time system intelligence and analytics for our microgrid demonstrations. And they will be not only monitoring a whole bunch of points within the system, both on the AC and DC side, but also looking at the energy dashboard to net out what's going on in the system. And those dashboards will not only be near the microgrid downstairs, but also up in the educational area, giving constant access through internet links to the operation of the microgrid as it is performing down on the show floor. So don't miss, if you haven't seen a really comprehensive real-time system intelligence and analytical system work in a microgrid environment, this is your chance. WES, or Worldwide Environmental Systems, does a phenomenal job at it. So that's all going to happen in and around booth 4146, but really in the larger Smart Energy Hall that booth is in. It's a pretty large area, so you won't miss it, and you'll see our DC lighting overhead. So I'm going to ask Greg. Did we have questions that we should take on at this point, Greg? Because I think I'm just about finished on the presentation side.
We do, Brian. Thanks again for all the questions that came in. And I'll add just one note here before we bore you a little bit more about some of what's happening at the microgrid. I don't know if Brian actually mentioned that it'll actually be a live microgrid on site at Solar Power International, powering how many booths?
Really not sure of the count, but it's probably in the 30 to 40 range.
So it's a unique opportunity for you to come and actually interact with all these suppliers that Brian ran through, and to see a live microgrid on site, because microgrids, as you know, can be small to more utility scale size, which leads me into the first question here. So first off, too, we'll be sending a recording of this webinar out to everyone because I know it's 3 o'clock right now, and this is scheduled for 2 to 3. So we'll email that out after this, along with the PowerPoint presentation, so you'll have that on hand. But Mario asked, so since Microgrids represents a thread to the existing utility business model, how can we expect market growth there, and what sort of market growth would we see in the area of microgrids?
Okay, well, I like the way you said that, because it's not a threat to the utilities, but the threat to the traditional utility model, but not entirely, because there'll be parts of the system that will operate in the traditional normal way. Just as today, some of the backhaul in the internet still operates very much like the original Bell system did back in the 50s and 60s. So that part is important. The other part that's really important is that electrification is really moving, if you want to look at it again as a glass half full side, which I tend to look at it, is that the enormous amount of electrification that's going to take place is going to challenge all of us on all sides, whether, both sides of the meter, whether it's a utility or private enterprise or what have you, or prosumer, because there's such a large expansion requirement there. So we have a number of utilities that are involved with eMERGE and have been for a long time. And we always make it clear to everybody that the mission that we're after is to provide enhancement for the entire system, where we don't marginalize the investments in traditional investments in what utilities have done in a miraculous way over the last 100 years or so. So I see that the saving grace here is the expansion of electrification that is going to take place over the next 20 years or so. I hope that answers the question.
It does. Thank you. Let's see here. What do we have next? So next question comes a little bit, I think, more general. It'll be hard to answer pending the project, but what is the cost for a typical microgrid? And maybe break that out into like going from building to utility to community or subdivision or malls. Like, what are we looking at from start to finish on something like that?
You're right that it is an impossible question to answer, because the answer does change very much depending upon what you want the microgrid to do and so on and so forth. I can say that it's becoming more and more clear that the value proposition isn't based on a simple calculation of a kilowatt hour cost or a kilowatt hour price. You need to take the total cost of ownership, including the bouts with resiliency and reliability in systems that we talked about. So it really does depend. I like to answer it, or at least think about it on a personal level, as I used to pay, I think, about $25 for my phone bill when it was just a phone. And now I think with the kids on the line and everything else, I'm probably paying something north of $200 or $300 a month on what you would call a phone bill. It's hardly a phone bill anymore, because it includes so many other values that maybe even outweigh the basic functionality, original functionality of it being a phone. I think electricity has the same potential. First of all, in a defensive way in terms of resiliency and reliability and all that. But as we go down into the articulation of power and the things that power can do for us, electricity in particular can do for us, as we make it more available in a more articulatable form, that the value proposition is going to be very positive. I mean, when you look at it on scale, if you look at it utility scale kinds of microgrids, they're already talking about power purchase agreements where the total cost, including amortization of capital and so on, is approaching in the 3 to 4 cents a kilowatt, if you want to measure it in the good old kilowatt hour, cents per kilowatt hour way. But again, the investment levels are, in my opinion, leveraged or in the value proposition. So it's very important that you have that you want and desire and can utilize the value created by the kind of microgrid that you install. I'm sure there'll be people out there that do it just for fun or do it because they want the newest, shiniest microgrid on the street. But matching of the functionality of microgrids to the value that they create is going to really dictate that return on investment.
Perfect. Thanks, Brian. Another question from Joshua here said, for systems without AC inversion, how far along are we with NEMA standards for outlets for low voltage devices?
Well, there are some standards that already exist that I happen to be active with NEMA and IEEE and IEC, and there are a number of connectors already in play, even in hot pluggable higher voltages like 380 that we, in fact, you'll see that we use in demonstration. There are, of course, a lot of traditional connectors that come into play, including at the fringe. We're seeing a lot more USB-C, PD, the power distribution, probably going to top out at that 20 volt range or so that computers use. And PoE, same thing in the 24 and 48 volt range. Already connectors are available for all of that. I think where the uncertain area it comes in is what I call sort of standard or dumb power connectors, which largely in the DC world have been barrel connectors or the so-called cigarette lighter type connector. But I think we're going to see over time some replacement of that. Again, the use of connectors that look more like the USB type or the PoE type, maybe in more ruggedized forms and so on. And in the higher voltages, you know, the traditional DC connectors are already there. They're available from the traditional connector companies. I probably shouldn't mention them, but I'll say like TE and Hubble and Anderson Power and so on. So there's lots of folks out there with DC connectors that can do the job already. But I do think, as you suggest, there'll probably be some additional streamlining that can be done through the mechanisms at NEMA and IEEE and EC. So I know that isn't a perfect answer, but connectorization at this point shouldn't hold you up in a big way. There's lots of choices out there.
Okay, the next question, do you see microgrids being built in regulated states by entities other than utilities? And if so, how would the cost of these microgrids be recovered?
Well, most of them are, the ones that we see being built are still what I call standalone microgrids, so they're not being networked. So the value proposition that comes from the notion of neighborhood or community microgrids, where you start to share resources, so you, if you will, you get better utilization of the assets in a shared system like that, where you have multiple tenants or multiple buildings that can actually share power, because nobody really uses power all at the same time. And there's lots of different ways to balance the system that way. And it also helps the utility because it tends to take a lot of the peaks and valleys out of the loads you know, during the operating day. So that's part of it. But I think, again, you need to look at the value proposition that your particular entity might have. A lot of entities like data centers will look at cost of downtime or reliability, or and then as they see that you can get to a higher level of that, look at the cost of electricity and the higher efficiencies that you can get by using, for example, DC with fewer conversions at higher voltages. Again, it's a mixed bag. It's a lot like the total cost of ownership question or the return on investment question. The most important thing is to do your calculations ahead of time and there's more and more software and services that will help you determine the value proposition and how it lines up with the investment that you might make in a microgrid. So that would be the direction that I would head. And again, these are good questions to bring to the Ask the Experts Clinic, because people who are involved in microgrids are faced with these questions all the time, and will have at the ready some guidance on how to make your calculations.
All right, Brian, we're going to take one last question here because we're running short on time. Actually, it's a two-part question, so I guess you get two here. First off, from the issue of cybersecurity of microgrids, what's being done right now in that space? And then the second question could be partially related but a little different is, does eMERGE offer any regulatory assistance working with state and local level policies?
Okay, two parts. Let me take the first one on cybersecurity. There's a lot going on in cybersecurity domain. It's not unique to microgrids. It actually applies almost the same way to macrogrids and traditional utility grids, and anything that's operational for that matter. If you're running a factory or a defense unit of some kind or a military unit, they all have the same issues of cybersecurity. So there are lots of advances in that area. The one additional advantage that the microgrid approach gives you is this ability to island and to sort of firewall and break up the system into so many pieces that it's hard to intervene and control it from any kind of central point. And it's kind of reminiscent of what Y2K, if you remember, when everybody forecasted that the internet was going to come crashing down and banks were going to go bankrupt or whatever, and insurance companies would lose your policies and whatever. And I think you can all recall with me the fact that really very little happened on the turn of the century, and that's because it's such a disaggregated system that it's hard to really cause that kind of a problem that would go that far in the system. And I think one of the things that at least the companies that I see operating in the microgrid domain are careful to incorporate and point out is this ability to sense non-normal operational directives and things like that, and to be able to island or isolate until verification, you might call it policy parity, can take place. So that's my answer on the cybersecurity. It's part of life now, and there are lots of folks working on it, and I think they're making good progress, despite the rumors that the Russians are still in charge. The other part of the question was on eMERGE and how we're influencing regulatory. We don't spend a ton of time with the regulatory folks other than by providing information. What we like to do is to provide networking opportunities with our membership. So to make sure that our membership is aware of regulatory issues that are coming up, and to provide some opinion on them. But we also, eMERGE is really a networking entity. So we network with, as I mentioned before, the Solar Energy Industry Association, the Smart Electric Power Alliance, NEMA, IEEE, IEC, CABA, and just there's a host of other organizations that we network in, and we all try to provide a collective, collaborative, and united front when it comes to advising regulatory or any policy-making bodies, including sessions with Congress and with the administrations in the White House and the Department of Energy and so on. So we take a collaborative approach to that, but we're not viewed as a sort of a lobbying organization to to try to, in a very direct way, influence regulatory policy. So I hope that answered it. Okay.
All right. Thanks, Brian. So that's all we have for today. Again, we'll send out a recap of all this in an email likely towards the end of this week. And you'll have both of our contact information, and feel free to reach out if you have any questions directly. Otherwise, we'll catch you next time. Thank you.